Hi, I'll be going through question 5 on promo paper 2. Alright, so let's look at this question. This is a circular motion question. So let's highlight some of the key terms first as we go. Alright, so we're going to have a steel ball projected at high speed around a circular bank smooth track as seen in figure 5.1. Maintains a constant circular path on the track at a constant speed of v. Okay, radius is 25 meters. Mass of the ball is 2.5 kg. Resistive forces can be ignored. Alright, then you have to be very careful because this view here is the top view. Alright, so you're viewing from the top. Okay, so the track, if you look right, the track is actually a bowl shape like this. The ball is going around this side. It's basically going in a circle like that. Alright, and this view here is you're basically viewing from the top down like this. Alright, so this is your bank track. Okay, then later the next picture we are showing you the cross-sectional view. So I'm showing you, if I take my original diagram, I'm showing you this portion here. Let me zoom in for you. I'm showing you this portion here. The ball is here. Alright, okay, so you have the angle, 15-degree angle over here. Alright, and you, for part A, you're supposed to draw and label the forces acting on the ball. Right, I think it's quite straightforward. There are two forces here. I'm just going to draw them quickly in blue color here. So we're going to write this down. Remember, you're expected to write out the names of the forces in full. You cannot just leave it as W because I assume they don't know what W is. Okay, so this force has been vertically down. The next one is your normal reaction force, or normal contact force. This one has to be drawn at the right angle to the surface. It's a perpendicular force, right? So this is normal contact force. 2 marks. Okay, make sure you label the forces in full. Yeah. Okay, next, ask to calculate the speed v at which the ball travels while maintaining the same radius of its circular path. Alright, this one, we need to do a few things first. We need to establish where the center of the circle is. Alright, I will just use, okay, let's draw another diagram here. Okay, so I'll draw this path. Just now we say it was like this. Okay, the ball is here. The ball will be traveling around like this way. Okay, so your center line is actually over here. Alright, and the distance, the radius is actually this distance. Alright, is this distance here. This is the distance r that you have. Alright, and did they give you r? Yeah, they give you r. So this is 25 meters. So this is equals to 25 meters. Right? And then we have to, therefore, in order for your ball to go in the circle like this, alright, you need to have a centripetal force, a net force that's pointing in this direction. That will give you your something that will give you your centripetal force. Okay? So if you look at the original forces here, right? Okay, I'm just going to draw this at the side again. So let's say right now the ball is over here. Okay, I'll draw in the weight component. Okay, this is my weight component, and this normal reaction force can be broken down to two parts. It can be broken down into ny and nx, the vertical component and the horizontal component. Okay, so I'm just going to draw it here. This will be ny, and then this is nx. Okay, because I know that in the y-axis, right, the ball is not going to go upwards or downwards. Okay, it's just going to stay at this height. So that will tell me my ny is equals to w. Okay, so in my y-axis, my ny is equals to the weight. Okay, then in my x-axis, right, my nx will therefore be my centripetal force. Okay, or you can write this as a net force. Okay, net force, and this is equals to my centripetal force. Right, so we can work to that. Alright, so maybe let's start off by writing, let's try to find n first. Okay, then later we can go and find out what is ny and therefore nx first. Right, so let's write this out. So first we can write for the y-axis, right? I can say that, okay, f net is equals to ny minus w equals to 0. So this will give me ny equals to, what's the weight of the ball again? 2.5 kg. So 2.5 times 9.81. Okay, and then I'll get 24.525 newtons. 525 newtons. convert this to normal reaction force, and this will just be ny over cosine 15 degrees. Alright, because here we can see that, okay, let's just draw this vector to the side over here. Let's draw it here. Okay, so this is my n, this is my ny, this is my nx, and this angle here is 15. This is 15. Alright, so ny is equals to n cosine 15. Right, so continuing over here, n is equals to 25.39 newtons. Okay, so this is for y-axis. Okay, so now we can use the, for x-axis, we know that my net force in the x-axis is equals to the centripetal force, and this is equals to nx equals to mv squared over r. Okay, so now we just find n sine 15 equals to mass of 2.5. V squared is what we were supposed to find. R is equals to 25. Okay, you solve this, you get V to be equals to 8.11 meters per second. Right, some of the common mistakes for this is that some of you assume that this is a circular path like that. Or a lot of you assume that this is a circular path. It's not. It's a circle itself. Right? So just be careful. For circular motion, it's really important. The concepts are very simple, but it's really important for you to make sure that you understand what the true situation is. Alright? Okay, that's all we have for question 5. Thank you.